All right, now we're solving, right? So we're going to use the log techniques for solving equations that we learned in the last lesson, but now we have to integrate them with the properties of logarithms. So when you're solving a log equation, your first goal is to condense it into one single logarithmic term if possible, right? So if you look at this, there are three terms, right? You have 1, 2, 3. Two of those three terms are logarithms in the same base. The third term, number 3 there, is not a logarithmic term. So in that case, the goal is ultimately condense the log terms into one log expression and then convert it to an exponential scenario. So what I'm going to do is I'm going to convert these two log terms right here, right? And you can only condense these two if the base of both those logs are the same. They're both in base 2. So we can condense it. This addition right here is going to indicate a product. So really what we're dealing with right now is x times x minus 2, right? That's what it's going to condense. The arguments are going to condense. So I'm going to distribute x to x minus 2, and now I'm dealing with log base 2 of x squared minus 2x, and that equals that original 3 right here. At this point, once you have a single log on the left side, you can now convert this to an exponential relationship where we're basically taking 2 right now, right? 2 raised to the third power equals x squared minus 2. That's what we have going on right there, right? And now this is a quadratic equation. So now we have to solve this quadratic equation. Typically, when you have 3 unique terms in a quadratic, right? So that's a quadratic term, x squared, a linear term, x to the first, and then this constant term over here on the left. You want to set it equal to 0 and attempt to factor it if possible. If it doesn't factor, quadratic formula is the way to go. So on the left, 2 cubed becomes 8. And then we have x squared minus 2x, set it equal to 0, subtract 8 from both sides. Now we're here. We're going to try to factor this. We're looking for 2 factors of -8 that also add to -2. That's going to give me x minus 4, x plus 2. Use the zero product property to isolate x. So now we have x equals 4 and x equals -2. You must check your solutions with log equations, not because we think you're doing it wrong, but because when you're using these properties, we've created a quadratic equation, right? The solutions to this green quadratic equation are 4 and -2, but are they the solutions to the original logarithm? We have to check. So we're going to check x equals 4 and x equals -2. So first check, we're going to take 4, substitute it into the original logarithmic equation, not a manipulated version of it. And ultimately, you're looking, does the value of the variable we're checking right now produce a 0 or a negative inside one of those logarithms? Ultimately, you're really checking to see, does the equation check out and work? But if the value of your variable produces a negative or 0 inside the logarithm's argument, it's not possible. So we're going to check 4. So log base 2 of 4 is 2, right? 2 to the second power is 4. So this, and then log base 2 of 2 is 1. 2 plus 1 is 3. This one actually checks out for us. 3 equals 3. Now let's check x equals -2 right here. So when we're checking this one, log base 2, this first part here, right here, log base 2 of -2, the inside the argument right now is negative. Right? Remember, it's not the positive negative sign of the solution you're checking. It's once you substitute it into the equation, does it produce a 0 or negative? So in both of these logs, when I substitute -2 in to check, I end up with negatives in both my log arguments. Not possible. You cannot take the log of a negative value or 0. Therefore, -2 is considered extraneous, and we move on. So there's only one solution here. But the bottom line is you have to show your check in order to, get full credit for this question that we're dealing with. These are 2 more examples just to run through, right? So the first one here, in order to deal with this, we are just simplifying. We're not solving. So it's just more practice with logarithms. So first thing you need to do is address this coefficient here, bring it up here. All right, so now we have 64 to the 1/3 here. Remember, this exponent of 1/3 is really a cubed root of 64. Cubed root of 64 is 4. So that first log becomes log of 4. Second term, same thing. I have a coefficient of 2. It's now going to become an exponent, 5 squared. 5 squared is 25. So now we have log of 25. Lastly, we're still, right, both of these logs are in base 10. You can only condense this further if they're in base 10 here. We're adding, that's going to turn into a product. So we're really going to multiply 4 and 25 here, which is 100. So I get log of 100. Remember, the base is 10. So log base 10 of 100 means 10 to what exponent is 100. So this is going to simplify not to 10, but to 2. Right? So the answer there is 2. Next one, we have 3 log terms. So just, go in order. I like to, one thing you could do is factor out a negative from the last 2 terms if it makes life easier, but you don't have to. I particularly like this process. And that allows me to not have fractions within fractions when I start using the properties. So I'm going to deal with the log of 6 and log of 5, and I'm going to factor -1 out right here, right? So now I'm dealing with this group here, right? And I want to do that because that creates a plus, an addition, right? Which allows me to condense 6 and 5 right now into 30. So that the right side becomes log of 30, but it's being multiplied by that -1 here. And then from here, these 2 logarithms are in the same base. So this subtraction right here is going to create a quotient or a division for me. And from that point, what I'm going to do is divide 3 by 30, which is going to leave me with right here, which simplifies to 1/10, right? Now remember, if we can produce an exact value here, we should. So the log of 1/10, remember, 1/10 is 1 divided by 10 to the first. I can write this as base 10 to the -1st, right? Giving me log of 10 to the -1st. Use that inverse operation, right? This base right here is log base 10 of 10 to the -1st. So the answer is just that exponent there, -1. Most of your assignment is solving log equations, condensing and expanding. And feel free to check in if you have any questions.